Greetings. Today is in embedded microcontrollers. We shall see about the ports. So the ports of PIC 18 is taken as example. You can see here you have 18 pin chip, 20 pin, 40 pin, 64 pin and 80 pin. So you have different kinds of pins, and in case of a PIC 18F1220 you can see you have only 2 ports, whereas in PIC 18F2220 3, and similarly PIC 18F8525 you have about up to L. So you will have more number of ports that's available, and depends on the version. So you have some kinds of special function registers that's related to the ports, and each ports will have about 3 registers related to that. For example, when you have a port A, you have port A register, you have latch A register, and you have tri-state A register. So port A is a register where you can have the output. So the values at the output or input will be present in the port register. And the tri-state is a register which is used to configure a port as an input or a output. So you can see the example diagram. You can see you have a tri-state which is wherever you have 0, it is an output port. It is configured as an output. Wherever it is 1, it is configured as a input port. So you can see the output port is connected to an LED, and an input port you have some values that's coming inside. The arrow shows whether it's output or input. So the configuration can be done by using a tri-state register. Port is a pin where the data come in and go out, and the latch is another special function register used to understand the status of the port pin. So whatever value is given in the port pins will get reflected in the latch register. So each port pins are related with, or each ports are related with 3 special function register, namely the port, latch and the tri-state. So here, before going into the port architecture, you can see CMOS, P transistor, PMOS and NMOS transistors together. And in one case, in the P type, you can see that when the base is given 1, it is an off state, and similarly when the base is 0, it is an on state in the case of a P type. And in the N type, when the base is 1, it is on state, and 0, it is a off state. And similarly when this becomes a CMOS gate, you can see PMOS and NMOS put together, its complementary metal oxide semiconductors. And you can see here, when logic 1 is given, or 5 volt is given in the PMOS, it is a off, and when logic 1 is given into the NMOS base, it is a on state. So whenever this is off, your PMOS, it is it's off, so you will not have any output. Whereas in the case of an NMOS, when it is on, it is connected to the ground, so the ground value will appear as the output. Similarly, when the input is 0 volts, your PMOS will be on, and since it's connected to the VDD, that 5 volts will be the output. Whereas in the bottom NMOS, it is in the off state, so since it's connected to the ground, and you will not have any output, and it's cut from the value. And now this is writing a 0 to a pin in the PIC 18. So you can see that here this is a port, output port. So what you have to do, the tri-state register has to be given a value of 0. So you can see you have 3 flip-flops. The upper flip-flop is a D latch, data latch, and the center is tri-state latch, and another flip-flop is a read enable register, flip-flop, Q flip, D flip-flop. And you can see at the center you have a tri-state 0. So when tri-state 0 is given, your Q output becomes 0 there. So since it's 0, and again when you write a value of 0 into the data bus, the Q dash value will become 1. So the input to the OR gate is 1 and 0, so the output is 1. Similarly, AND gate, 1 input is 1, and as we have given tri-state as 0, the Q dash in the middle flip-flop is 1. So you have 1 and 1, AND gate output is 1. So both the transistors will have 1, as we know that in the case of a P type, when the input is 1, it is off, and in the N type transistor, NMOS transistor, when the input base is 1, it is a on. So since the P transistor PMOS is off, it's totally cut, you need not worry about that. and the below NMOS is on. So since it's connected to the ground, the 0 value is moved to the output. So this is writing a 0 to the output. Similarly, when you want to write 1, again the same concept. You have a tri-state as 0, and to the data bus a value of 1 is written. So as 1 is written, the Q dash will be 0 in the upper data latch. And similarly in tri-state, as tri-state is 0, the tri-state latch Q is 0, Q dash is 1. So in case of this, the values, binary values, we are looking at the binary values in the OR gate and the AND gate. So the OR gate output is 0 and the AND gate output is also 0. So as you have a 0 to the base of the PMOS transistor, it becomes the on state, and 0 to the NMOS transistor becomes in the off state. So as PMOS transistor is on, the value VCC value goes out, so a logic 1 will be sent to the output. So reading a value from the output, so that is inputting or reading a value. So what you should understand, one should understand, is the whole circuit should cut off and the value from the output should come through the bottom D flip-flop. So you can see here the tri-state is 1. So when it becomes 1, you can see the values to the AND gate and 1 to the OR gate. So what will happen, even if one input is 0 to the AND gate, the output is going to be 0. And the one input is 1 to the OR gate, the output is going to be 1. So both the transistor are off, the PMOS transistor and the NMOS transistor are off. So as these two are off, the whole circuit gets into a high impedance state, that is, you don't have any values to send to the output. So this will be acting as an open drain. So whatever value is read at the output pin goes to the buffer. You can see a latch, and then it goes to the bottom D flip-flop. And when a read signal is produced by the processor, this 0 value is passed to the Q output, and again this read signal will go as an enable pin to the tri-state latch. That 0 value will move to the data bus. So this is reading a 0 from the output. Similar, the same concept again, reading a 1, the total input gets off because the input to the base of the PMOS is 1 and to the NMOS is 0. So both the transistors are off now. Now when a 1 has to be read, the 1 will go to the lower flip-flop, and a read signal produced by the microprocessor will enable the lower flip-flop and also act as an enable pin to the tri-state latch. So this value is moved to the data bus, so the processor can read it. So these are some alternate functions of port A. Port A, as we can see, it's a normal input output port, as well as the alternate functions will be analog and timer 0 clock, as well as oscillators clock 0. And port B, it can be used for the interrupts, it can be used for the CAN and all power related work. Port C is for serial communication, timer, and again pulse width modulations. Port D, again it's for PSP, SP, and again you have some kind of input output ports. Thank you.